Ethane reacts with chlorine to produce chloroethane and hydrogen chloride. This is an exothermic reaction. It is not possible to measure the enthalpy change for this reaction directly, but we can calculate it using mean or average bond enthalpies. However, this method gives a slightly different value to that obtained using Hess's law. To understand this, we need to calculate the enthalpy change of reaction using mean bond enthalpies, describe how mean bond enthalpies are determined, and explain why we can only calculate an approximate enthalpy change of reaction using mean bond enthalpies. First, we rewrite the equation using displayed formulae so that all of the bonds are shown. We imagine that during the reaction, all of the bonds in the reactants break in an endothermic process to give separate atoms. We then use mean bond enthalpy values to work out the amount of energy needed to do this. Breaking the 6 carbon-hydrogen bonds requires 2,478 kilojoules per mole. Breaking the carbon-carbon bond requires 347 kilojoules per mole. And finally, breaking the chlorine-chlorine bond requires a further 243 kilojoules per mole. So, the total amount of energy required to break the bonds in the reactants is 3,068 kilojoules per mole. Energy must be put in to break the bonds, so this value is positive. We now imagine that the atoms join together in an exothermic process to make the product. We use the mean bond enthalpies to calculate how much energy is released. Making the 5 carbon-hydrogen bonds releases a total of 2,065 kilojoules per mole. 1 carbon-carbon bond is made with a bond enthalpy of 347 kilojoules per mole. 1 carbon-chlorine bond is made with a bond enthalpy of 346 kilojoules per mole, and 1 chlorine-hydrogen bond is made with a bond enthalpy of 432 kilojoules per mole. The total amount of energy released by bond making is 3,190 kilojoules per mole. Bond making is exothermic, so this value is negative. To find the enthalpy change for the reaction, we simply need to add the total amount of energy required for bond breaking to the total amount of energy released by bond making. We can make the calculation simpler by considering that only these bonds make or break during the reaction. This gives the same value as when we included all of the bonds in the calculation. Using Hess's law, we can calculate the enthalpy change of reaction based on a thermochemical or enthalpy cycle and measured standard enthalpy changes of formation. This gives a different value to the one we obtained using mean bond enthalpies. The reason for the difference is that bond enthalpies actually vary from compound to compound. Mean bond enthalpies are average values, so do not correspond to the actual bond enthalpies for the compounds we are considering. So to find the exact enthalpy of reaction, we need to use Hess's law and known enthalpies of formation for the reactants and products. So, we can use mean bond enthalpies to calculate approximate enthalpies of reaction by imagining the bonds in the reactants being broken and the bonds in the products being made. But we need to use Hess's law and known enthalpies of formation of the reactants and products to get more accurate values.